I will talk today about the development of and the usage of Internet of Things in healthcare. The development of computer technology in general, and especially wearable devices, Internet of Things devices, impacted all aspects of human activity lately, and the prices of such devices are very low, even to the end user. And the IoT is one, and the IoT is one of the most intensively developing technologies also in the area of healthcare. The technology has allowed the creation of a variety of devices for measuring and monitoring the vital signs of people that are in addition to the specialized medical equipment that's already existing. And there are many IoT devices for monitoring vital parameters that can be used both in hospital and in outpatient setting. Okay, so those IoT devices can record the received information locally or use mobile communications to transmit it in real time to specialized platforms. There's really a huge variety of such IoT devices at the moment, and they're available on the market. I'm sure that most of you here have such, like smartwatches. I have one, for example, fitness bracelet, and there are also specialized solutions for monitoring certain parameters of the body and the environment during people's daily activities. The collection of large amounts of diverse information like this can improve the diagnostic activity in medicine, and also it can be used to monitor the process of post-hospital recovery. Currently, the devices can record not only your heart rate, like the devices we use in our everyday life, but there are more advanced devices that can record EKG, blood pressure, sugar saturation, and even more. I will start by showing you one such device, which is called the Hexoskin. And the Hexoskin is part of one rapidly developing area at the moment, which is smart garments. This is actually a shirt. Recently, we have purchased one Hexoskin for a project at the university. And the Hexoskin has also improved version, which is called Astroskin. Both are developed with collaboration with the Canadian Space Agency and give very accurate readings. The garment itself includes textile sensors that are embedded into a relatively comfortable shirt. I say relatively because it is pretty tight in order of the sensors to work correctly. And it gives a precise and continuous cardiac respiratory monitoring. The Hexoskin has one lead that provides electrocardiograph, and the Astroskin provides a 3-lead cardiograph. Just as a comparison, the EKG devices that are used in the hospitals where you lie down, you strip, they use sensors, and the halters, those are medical devices for continuous monitoring, use 5-lead. So we are not there yet, but we are moving towards this direction. What is interesting in the Hexoskin and the Astroskin is that they have event detection. The software that is applied with the smart garment can detect QRS events, and it has 3-axis accelerometer, which can detect fall events. First, I will answer what is QRS event. This is a medical term that refers to abnormality in an EKG. Basically, what you see on the presentation is one wave of the EKG, and those QRS are just points in the EKG. Any abnormality there, there are strict there are values in which those 3 points have to be. Any abnormality in those can be caused by some kind of heart condition. And what is interesting is that such smart garments have the potential in future to replace medical grade device, like for example, the halters. As I said before, halters are medical devices that continuously gather cardiac data, only cardiac data, and can be used to diagnose heart conditions. And I don't know if any of you have worn a halter, but I can tell you from a personal experience that it is not a pleasant one, since it is not so small, at least a little bit older ones, and also they have wires everywhere, and you have to wear it the whole day in order for the medical personnel to get the data and analyze it afterwards. While a smart garment is much more convenient and patient-friendly, plus it provides additional data that is breathing volume, breathing rate, and temperature. When you add to that the fall detection that can be achieved using the 3-axis accelerometer, it has the potential to become very useful. And even though it is not yet considered a medical device, because it lacks the accuracy of the halter and has not undergo clinical trials, as far as I know, it can be still very useful, for example, in elderly homes for people with chronic conditions, like, for instance, chronic heart disease, because just imagine living somewhere remotely, and for example, you faint from low blood pressure. The Hexoskin can detect this fainting event and send automatic notification to a monitoring center or a medical personnel, which is very, very useful. I will show you the garment, and I will do something that most probably I will be the first one that will do on this conference. I'm going to undress myself a bit so that you can see it. So this is the garment. I hope you hear me still. As you can see, it looks just like a regular shirt. What is interesting, I don't know how where you see it, but on this area, the fabric is a bit thicker. And here, actually, you have the EKG sensors that are embedded into the fabric. And on this side, there is a little thin cable that goes into a pocket. And in this pocket is the actual device. This is the device of the Hexoskin, which is currently working, and it is paired with my phone. It's a little bit difficult to show it on this camera, but I hope you see it. The device has to be worn on a naked chest, and the leads have to be wet, either with water or this conductive liquid that's used in the hospitals. And once you start it, you can open the application that comes with the Hexoskin and see the data that it provides. I wanted to share it on my screen, but I have a problem with the tool that's sharing it. So I will have to show it on the camera. Let me just try it one last time. I think I will be able to share. Just a second. Because the application is on my phone, and I'm currently waiting for it to connect. But yeah, it won't work. Okay, I will just try to show it on the screen. As you can see, this is the application. I don't know if you can see it well, but as you can see, my BPM, my beats per minute of the application are quite high at the moment for me, maybe because I'm speaking. There is also respiratory rate, and the third metric is the lungs volume. If you, for example, if I start breathing a little bit more often, you will be able to see that the number should increase a little bit. And also, if I switch, you can see the real-time feedback from the sensors. This is my EKG, and this is the breathing rate. Here, the interesting is that if I breathe deeply, the graphic spikes immediately. It has a very fast response time, and keep in mind that this is being transmitted now through Bluetooth to the phone. And also here you can get the accelerometer, which is pretty flat, but if I jump now or if I fall, it will produce the same spike as well. All this data is stored not only on the phone, but the device itself has internal storage that can store part of the data, and after the data has been uploaded, it is also stored on the servers of the Hexoskin, and it can be accessed, and you can create your own software for analysis of this data. And the only thing you have to do is just use OAuth in order to be able to authenticate to the server. So the next thing I want to talk about is the Libre, the Freestyle Libre glucose monitor, which is another device. It is a more common device that has been around for years. It is a sensor that can be used to track blood sugar, and it is especially useful for people who have the diabetes conditions. These people have to monitor their blood sugar levels as a part of the treatment. And usually the test for the blood sugar requires for you to use a needle and get some blood, very little, but still puncture your finger and analyze the blood. The Freestyle Libre sensor eliminates the need to use the standard blood sugar test because it is inserted only once into the upper arm and can stay there up to 14 days, where you can do pretty much everything with it. And the best part is that it is absolutely pain-free. I cannot imagine how annoying it is to have to do the standard tests every day. And I'm sure that some of you have seen this because it's been a while. It's been around for a while. Here the more interesting part is the next thing. I saw this. The man on the left is the greatest marathon runner of all times. Recently, he did something that was considered impossible. He ran a marathon in under 2 hours. And I saw the same sensor. If you check his arm, I saw the same sensor on his arm. And I was curious why he was wearing, because it would be very difficult to run a marathon if you have diabetes at that speed. And then I saw the same sensor on the man on the right. The man on the right is called Christian Blumenfeld, who won the Olympic triathlon gold. So I checked about this and find out that there is a company that creates a software which can use the Freestyle Libre sensor readings in context of sports to support fueling, because every aerobic sport uses at some extent sugar to fuel the muscles. And I was surprised how many athletes use this. During the 2020 Tour de France, some of the teams used it to get their fueling right on their bike computers during the competition. So they're riding their bikes, they have small computers on the bike, and they see the blood sugar in real time. As a result, of course, the International Cycling Union banned the sensor in their competitions, but still the people continue to use it while training to improve recovery. And this is a very interesting trend, as it seems a medical device, IoT device, is currently being used to improve sports performance. And not only that, it seems that after I checked, Christian Blumenfeld, the guy at the right, uses quite a lot of such sensors that supply medical data to optimize his training outside of the usual bike tech. He uses devices that, for example, measure blood flow in the legs, temperature sensors, and also portable devices that can measure muscle lactate. And also, I found out that in the sports area, and not only there the so-called recovery advisors. The recovery advisors are especially popular in the sports field, but they're used also in everyday life. Most of those contain only heart rate sensors. For example, I have such a bracelet that has a heart rate sensor, but it uses the data in a slightly different way. Instead of measuring the heart rate itself, they measure the heart rate variability, or HRV. And here we'll get a little bit medical. HRV is the variance in the time between the heartbeats. So if your heart rate is, let's say, a 16 beats per minute, it will not beat exactly every second, but instead there will be some milliseconds difference. And although heart rate variability manifests as a function of your heart, it actually originates from your nervous system. Your autonomic nervous system, which controls the involuntary aspect of your physiology, has two branches, the parasympathetic and the sympathetic. The parasympathetic side is characterized as the rest and digest system that allows the body to power down and recover. And the sympathetic branch activates stress hormones production and decreases the heart contraction rate and force the cardiac output, and decreases the HRV, which is needed, of course, during, for example, exercises or mentally or physical stressful situation. Conversely, the parasympathetic system slows down the heart rate and increases HRV to restore the balance. The natural interplay between those two systems allows the heart to quickly respond to different situations. And when you have a high heart rate variability, it means that the both nervous systems are in balance, and that your body is responsive, and it is a sign that your body is very capable of adapting to its environment and performing at its best. This does not only mean sports performance, but I also mean handling everyday stress. This is very useful to handle everyday stress. The small compact IoT devices that measure heart rate variability, like the one I have, this is the so-called Whoop bracelet. Here's the link in case somebody wonders. It's just a heart rate sensor, but there the more interesting thing is the software, because the software creates a statistic, a baseline about your HRV, and provides insight when you are recovered and when you are stressed. And by having this information, you can adapt to the changes around you. For example, if you're stressed, you can slow down. And also, if you are exerting your body, you can see it very clearly. Since I'm using this bracelet, I have it since I think 8 or 9 months, and I wear it every day. The only 2 times that my heart rate variability fell really low, the next day I was sick. I mean, I had a cold. So this gives really good insight. And another topic regarding the IoT device is the telemedicine, which is especially useful during the COVID pandemic. The telemedicine is the remote diagnosis and treatment of patients by means of telecommunication technology. The COVID pandemic puts a big strain on the hospitals, and this becomes very important. There are at the moment devices like the one on the right that allow remote monitoring of patients, like for example, for example this one. This is actually a Holter, but besides being a Holter, with the 5-lead EKG sensor, it can also measure blood saturation, and it connects directly to the internet. It has a SIM card in it. And during the COVID pandemics, such devices are being used at the moment to monitor remotely patients. By having this device strapped on yourself, it can transmit data directly to a medical personnel, and for example, it can be seen when you get worse. And as a conclusion, there are really a lot of devices there that can be used in a hospital, or also in recovery to improve both those areas. And although some of them are not that accurate yet, in the future, I expect that those will be very widely used in hospitals. And even currently, I am working with a medical doctor from the anesthesiology department in the hospital to see how we can use those.